Hello, I'm Evgeny Goncharov. I'm in charge of one of Kaspersky's expertise centers, Kaspersky ICS CERT. It's probably better to call it operational technology cybersecurity, because we're not just talking about manufacturing, energy, and utilities. We also handle smart transport systems, smart buildings, and lots of other smart stuff. If I were explaining it to, let's say, engineers, I'd probably say this. Physical security means video surveillance systems and armed guards who protect a plant from intruders with guns or maybe just a crowbar. Automated emergency protection systems and everything they involve help protect the plant against, for example, a technician who made a mistake or fell asleep on the job. Cybersecurity of operational technologies includes all the products, expertise, and everything else to protect the plant from a bad guy with a computer. When talking to people already acquainted with the concept of protecting office IT systems from attacks, we can simply say that we're not talking about protecting against data theft or your laptop getting encrypted, but against a computer at the plant getting encrypted, which could lead to a production process being stopped, or files got damaged in a command and control machine, causing the machine to start making parts incorrectly, and so on. We protect against all sorts of different possible direct physical consequences of cyber attacks. The most common issue is system encryption. Getting encrypted leads to production shutdowns because it's not always clear exactly which systems have been compromised. Sometimes attackers reach automation systems, SCADA servers or servers where historical process telemetry data is stored. This often results in having to stop production. Sometimes blocking certain IT systems also causes production stoppages. If logistics-related IT systems are affected, and a system for recording everything that comes or goes gets encrypted, then the company probably can't operate as usual and will have to shut down the plant. These are the most common scenarios. Industrial cybersecurity, or operational technology cybersecurity in the broader sense, is just challenge after challenge. There are all kinds of unresolved issues out there. Issues with regulations, state or industry regulations, issues with staff shortages, issues with a lack of best practices, plus a huge number of purely technical issues that complicate the protection of industrial enterprises and production facilities against cyber attacks. By far, the most common is dealing with the consequences of crypto attacks. That might mean data theft and systems not working because they were encrypted. This happens at industrial facilities, and these industrial facilities might have to stop operations because of these attacks. Maybe because an automation system or one of its components was affected, or because it's unclear whether they were affected. In many cases, production systems are so tightly linked with other systems, from business processes and order processing to logistics, delivery of finished products, that if any of them are encrypted, production comes to a halt. The biggest losses I've heard about happened not so long ago. They weren't related directly to production, but vehicle sales and service. It was an interesting incident and illustrates many of the issues in information security for industrial enterprises and beyond. A software manufacturer and service provider for car dealers in America had their system encrypted. The attack cost the supplier something like $25 million, although this number is not confirmed. It's just the estimates of technical analysts who track crypto wallet payments. But for the company's clients, and there are a lot of them, 15,000 companies, the incident cost over $1 billion in direct losses. Losses due to unsold cars over 3 weeks, unprovided services, unsold parts, plus additional interest to banks under vehicle purchase agreements with clients, not to mention all the risks and problems with loss of business, clients, reputational damage, and so on. Huge losses over a 3-week period. Industrial companies have a huge supply chain, as do transport and logistics companies. Very complex products with lots of niche vendors. These niche vendors often lack the resources to ensure reliable information security for themselves. So, the suppliers of products and services, especially for industrial companies, are often the information security bottleneck for entire industries. An attack on one supplier can cause huge problems for the entire industry. A tricky question? Well, we've never hacked Chinese cars. We've hacked Chinese components for non-Chinese cars. The issue is that trying to make everything cheaper leads to the use of solutions that are harder to protect. If your car isn't just a reliable way of getting around, but has lots of different features involving IT services, like a gadget on wheels, then it will have way more attack vectors. Vendors who have been on the market for a long time already have good practices for ensuring product quality, plus experience dealing with information security problems. I don't want to name names, but I'll give an example of how one vendor handles things. A few years ago, we looked at the flagship car of one of the world's leading automakers and found a number of vulnerabilities, and we told them about what we found. Over about a month and a half, their product security contacted us, saying they had fixed all the vulnerabilities we found. Even then, several years ago, they had a team of cybersecurity specialists doing internal pen tests and processing information about vulnerabilities in cars and their components. They then flew in from Europe with all the components we found vulnerabilities in, with new versions of firmware and vulnerability fixes. They wanted to be absolutely sure that all the potential attack scenarios were covered and that they really fixed everything without leaving easy ways to bypass their fix. This shows how the company as a whole, how their whole team, quickly and responsibly addressed these problems. Not all car vendors are the same. There are a lot of problems with Asian vendors, not just Chinese vendors, but in other Asian countries. It's just how they do things. But in general, it's hard to say, yeah, all the cars from a certain country have issues. I mean, it's impossible to make a direct connection. I think it's practically impossible to do something with access to just an onboard multimedia system of a plane so that flight safety would be compromised. The very architecture of a plane's information systems doesn't allow for it. But it is possible to hack an airplane in a more general way if you have access to some of its other interfaces without being a passenger. Or you could hack the multimedia system. It's actually a pretty serious issue. It's probably a bit trickier with trains. Trains are in some ways more integrated into the infrastructure available to people. The railway industry has a lot of different types of equipment, railway stations, and a huge number of companies involved in maintenance. Incidents related to train safety are possible. As for high-profile incidents, not long ago, Polish researchers published an interesting case in which technical maintenance was ordered not from the train manufacturer, but from a third-party company. So, this third-party company got to work servicing the trains. The trains to be serviced arrived at the depot, the maintenance was finished, but the trains were stuck, not being able now to leave the depot. The cybersecurity researchers investigated and, in the end, found that some undocumented features had been added by the developers in the train's code. The logic was something like this. If a train is parked in some semi-off or fully off state at a location different from an allowed geolocation for longer than a certain amount of time, in other words, if maintenance is carried out other than at the developer's infrastructure, then a special train lockdown mode is activated without a clear way to disable it. These kinds of things are possible with trains and all sorts of other equipment too. Trains are also part of a complex infrastructure, including different logistics and transportation organizations, so that opens the potential for attacks too. Vessels are also important to mention. Many countries are increasingly concerned about the cybersecurity of their maritime transport, partly because there have been incidents where vessels haven't been able to leave the port due to cyber attack, shipping schedules delayed, and cases where the onboard computer systems have been encrypted. Cyber attacks have been proven to be possible, and it's crucial now to deal with the cybersecurity of ships and other vessels. They're huge, and depends on what the contractual obligations are, what's on board, insurance, etc. I'm not a shipping expert, but I guess the losses can run into millions. I've never met a perfect industrial cybersecurity expert. Maybe they've only just been born, or just started first grade, or are finishing school somewhere. There are pretty much two paths to industrial cybersecurity, and they kind of move opposed to each other. One is cybersecurity specialists, who for whatever reason get involved in the protection of all kinds of operational technologies. The second is engineers who understand production technologies, technological process, and automation systems, and who for various reasons were either forced to deal with cybersecurity, which is common, or they decided to dive into the details themselves. There's a certain synergy at the intersection of expertise between these two categories. It comes down to studying the possible consequences of cyber attacks on the behavior of certain industrial systems. The main interest is in consequences that could lead to a serious accident, failure, environmental disaster, or a threat to life. Equipment bound for a factory is manufactured in a special, robust way. It's prepped for low temperatures, high temperatures, dust, dirt, vibrations, and so on. In a sense, cybersecurity specialists who have to work in a factory or travel to these facilities also need to be prepped for dust, dirt, and not so comfortable conditions. Not just in the direct sense, but in terms of communication, too. People in industry kind of have their own language. It's just a little different. And the relationships between people, how conflicts happen, all this stuff, it's a little different there. You need to be ready for it. If we're talking about a large industrial enterprise, its facilities are often scattered over a wide area, which can present practical challenges, including issues like different backgrounds or reference points. And if you have to fly to drilling sites, for example, or work for hours on a noisy factory floor, you need to be prepared for that too. You'll need some soft skills to be robust and steady resiliency. Unfortunately, no, not normally. But if you need to investigate an incident and the system is physically located somewhere like I just talked about, then you need to go there and talk to the workers on the ground. It depends where. If we're talking about some factory out in the middle of nowhere, then probably not. There are probably some companies that can afford to pay above the market average, but I don't know how often that happens. It's likely less about what you're going to work with, but more about what kind of expert you are. Some cybersecurity experts are just super good at their job. They can do pure IT security work and also do the same thing for transport or industrial systems. If a company wants top talent, they offer more money. This isn't specific to the industry. It's about the cybersecurity market in general. Because in general, there's a big shortage of cybersecurity specialists. It's a global trend. To belong to the League of Industrial Cybersecurity Experts, you probably have to be an employee of a cybersecurity vendor working specifically for industrial enterprises. Or you need to work for a very specific industrial-related vendor that, for example, makes automation systems for an industrial enterprise or produces something as complicated as a car. For a regular industrial enterprise today, at this stage of cybersecurity maturity in most industrial enterprises, it's enough to just have a good cybersecurity specialist to start patching the holes that already exist. Many enterprises still aren't thinking seriously about the possible consequences and issues of a cyber attack on their production assets. They take some of their existing safety measures, like for functional safety, and say, we need to make sure none of this happens because of a cyber attack. They usually don't think about how this isn't the best framework to address cybersecurity. They're just not there yet. Let me give you an example. It's not technically the best, but just so you get what I'm talking about, there are 3 turbines. They're from 3 different manufacturers, and they have 3 different automation systems, as well as emergency protection from 3 different suppliers. In terms of functional safety, this is good, because if something breaks in one turbine or its automation system or safety system, then it probably won't also affect a second and certainly certainly won't be the case for all three at the same time. The probability of all three turbines failing at once is close to zero. But if a hacker penetrates the enterprise network looking to disable a turbine, they'll disable all three. Because in terms of cybersecurity, even if they don't all have the same security problem, the problems will be very similar. The attacker won't need to do 3 times the work, but maybe just 30% or 10% more than if they attack just one turbine. Or maybe it won't take any more effort at all, and they just write the cycle from 1 to 3. It's fortunate for us that while real cases of cyber-physical attack consequences do exist, but they are extremely rare. Every such case has a backstory. Firstly, monetizing these attacks is complex and difficult, so attackers focused on monetization won't even try. They want to make money fast and move on to their next victim. Secondly, these attacks may have serious potential consequences for the attackers too. Because if you don't just steal something, but people end up injured or dying because of you, or there's an environmental disaster, the incident will get a lot more attention and a lot more resources will be spent trying to bring you to justice. So, cybercriminals usually look for simpler, less risky paths. Sometimes I have to get out my drill or whatever and do something around the house. I like working with my hands, and sometimes all I want is clear, straightforward work. But that's not how things are for me. I guess I'm not done with things here yet. Regulations are key for cybersecurity because they're a main driver of everything that happens at an organization from the very start, and during operation, and right until the end. For almost every company, everything very much depends on the current regulator. Let's say we're talking about a nuclear energy facility. This is a complex and extremely long-term project in terms of design, construction, operation, and commissioning. If certain cybersecurity issues aren't included at the earliest stage of design, you'll most likely never be able to implement them in full later because it would be too hard to make any significant changes. In a lot of ways, to take cybersecurity into account correctly, and we've actually managed to do this in one of our consultancy projects, you need to understand that cybersecurity will influence the architectural plan of the facility and division of all of its systems and the facility's premises into protected zones, mainly for radiation and nuclear safety. The influence is massive, and it can't be compensated for later. It's like if you buy a car. You won't be able to protect it later just by installing an antivirus on it. The car needs to have some cybersecurity features built in from the start, and that means the car vendor has to add these features early. But taking cybersecurity into account at each and every step of your product life cycle might be a significant resource investment that many would rather avoid. That's why you need a regulator. It already works in some industries. For example, for cars, there's some regulation at the international level, in the nuclear energy sector as well. But when you start looking closer at the specifics, the local regulations and standards and methods for a certain country or territory may be insufficient or non-existent. For example, in many countries, there are still no working cybersecurity regulations for cars. We've already mentioned aircraft. Currently, technical standards for their cybersecurity are developed in some countries and are still being developed in others. I should also mention construction projects, whether it's a shopping center or power plant or something else important, or just a residential building that will have all sorts of different systems, like automation systems, elevators, energy, ventilation, and air conditioning. There are no regulations in place right now, globally or locally, sufficient to make a building cyber secure from the very start. As I said, this could have been a strong motivator for the people constructing these things to prioritize cybersecurity. We need things to be cyber secure by design at the legislative level, because there's legislation that forces safe by design, but not cyber secure by design. We're trying to make our important systems and objects safe in terms of functional safety, but taking cyber risks into account from the very beginning isn't done everywhere. But many of the technical standards are being developed, and Kaspersky teams have a hand in their development too. I hope some of them will start being used soon. Some of the latest generation solutions will probably never be implemented in their current form, but more mature, heavily updated versions of them likely will be, because in production, they prefer things that are a bit more time-tested and reliable. Some brave, forward-thinking people use the latest developments in a few places, but it's not a wider trend. In a way, a lot of enterprises are already using industrial IoT in a certain sense. In some industries, it's been going on for decades, like in the electric power industry, where there's huge object interconnectivity, remote monitoring, and remote control of systems, distribution networks, and so on. Smart meters used to only be available at certain production facilities or companies. But today, smart meters are used to connect even ordinary households. In a certain sense, this IoT isn't exactly industrial, but it's close. The Internet of Things has been around for a while. In some industries like mining, it may bring many benefits. Imagine you have a fleet of quarry trucks that drive around your quarry transporting raw materials, and you need to ensure that this is done efficiently without threatening the safety of drivers or facilities, without the threat that a certain dump truck will break down. There's a lot there you need to track. So a lot of telemetry and sensor data is collected. Now manufacturers of these dump trucks are rushing to make self-driving vehicles. The industrial IoT and edge computing will probably be in huge demand there soon. In logistics, driverless robots and other systems often operate alongside people. The top priority is human safety, ensuring robots can't injure or kill someone. Many industries rely on modern technology, but in some, companies take pride in the fact that not everything is automated and see no need for cutting-edge technologies. For example, I know of a steel rolling mill in Japan where they are proud of the experience and qualifications of their employees, who manually control rolling processes to guarantee the quality of their products. They say it's better than what you'll get in more automated factories. Not AI, not artificial, but natural intelligence. We're already there. It's just a long, complex process, and it looks different in different industries. But it has a snowball effect. The introduction of machine learning systems, AI, involves the need to merge a huge amount of data in the data center. And there's also the need to collect all this data from different sensors and so on. All this connected production, this is industrial IoT. If you have a lot of stuff to analyze, then you're probably going to have to make some quick decisions based on some of it. So you're not going to want to send everything to the faraway cloud. You'll want to keep some operational parts of it somewhere closer to the facility. This is where edge computing comes into play. New technologies depend on other new technologies. This affects and stimulates mutual development. Simply put, it's about executing code closer to the user, not in some distant cloud data center, but on nearby infrastructure such as a mobile operator's base station or other local equipment. Right now, it doesn't. So far, these new technologies are advancing faster than the implementation of certain tools, properties, and information security measures. This is typical for the early stages of any new technology. Some of what comes from AI systems in different areas of our lives has already been studied and predicted, but it's still hard to predict a lot of things because there will be lots of different applications, and once something is invented, other people will find out how to break it. Maybe in this instance, not even people, but AI. What the future holds is still unclear, but it'll be interesting. Cybersecurity culture should be part of production culture. Products, especially if it's something important for dangerous infrastructures or facilities, should always be developed with cybersecurity in mind. This makes life much easier for anyone trying to protect it, and in general makes the world safer. Everyone needs to invest in it. A lot of people are doing so now, and it's clear there's a conscious need for it, and there really is some movement in this direction. Maybe people being born now will have higher general literacy, not only IT literacy, but cybersecurity literacy, because they're born in a hostile environment in a certain sense. You go to school and hear stories about how someone's account was hacked, how grandma's money was stolen. So you start to do things differently than the guy whose account was hacked or money was stolen. Their brains are young, neural connections are built fast from unclaimed neurons. People learn everything faster, and they'll probably be better than us in many ways. I think the future of cybersecurity and industrial cybersecurity in general will be interesting. Protection will definitely be better, but attacks will be better too. We have a great product called Machine Learning for Anomaly Detection, developed by my colleague Andrei Lavrentiev and his team. It all started when they decided that in addition to the technologies already in use in our products to protect industrial systems, they'd use AI to analyze industrial telemetry data to try to find anomalies that could indicate potentially malicious activity. In its very first days of testing as a prototype in production, it showed that it can detect cyber attacks and also other bad events for an enterprise. For example, some bad or incorrect changes engineers made. There was a story, I think at the very first enterprise using this product, where a product of theirs went through a cycle. I won't say what the product was, but it went through a tempering cycle in less time than was required, so it would be possible to produce a larger quantity. And it turned out that this AI/ML product can detect many kinds of different anomalies and potential incidents. Right now, it's being used in the petrochemical industry and other sectors.